Have you ever wondered how your smartphone knows what to do? How does a video game create amazing worlds? Or how does your microwave know exactly how long to cook your popcorn? The answer is all around us, but it's invisible. It's a special kind of language that talks to machines. We call this programming. It's like a set of secret codes or like a recipe that tells computers step by step what to do. Without these codes, our favorite gadgets would be lumps of plastic and metal. They wouldn't be very smart. These instructions are the magic behind our modern world. Every time you send a text message, you are using a program. These programs are written in special languages that evolved over time. This is a journey through history to see how computer languages were born. From simple holes punched in paper to the powerful tools building the apps and websites we use every day. It's a story of science, of brilliant ideas, and of learning to talk to amazing machines. Long before modern computers, people had a big idea: make machines solve problems. They wanted to automate tasks to make things faster and easier. But how do you tell a machine what you want? You can't just talk to it. You need a very precise system. That need is where programming languages begin. It's about human ingenuity, about our desire to build, to create, and to connect the world. Get ready. We're traveling back in time. We'll explore clunky, room-sized computers. We'll meet the pioneers who wrote the first lines of code. Each new language was like discovering a new key, unlocking possibilities for what technology could do for all of us. This isn't just for computer scientists, it's for anyone who has used a computer, played a game, or sent a message. It's the story of secret codes that completely changed our world. Consider this. Let's set our time machine way back, to a time before computer screens, before keyboards, before a mouse. Imagine a giant room filled with a massive machine. It hums and clicks, lights blink on and off. This is an early computer like the ENIAC or the Harvard Mark I. So, how did people tell this giant machine what to do? They couldn't type on a keyboard. Instead, they used something much more physical. They used switches, wires, and something called punch cards. A punch card was a stiff piece of paper. The programmer would punch holes in it in a special pattern. Each pattern of holes represented a piece of information or a single instruction. To run a program, you would feed a whole stack of these cards into the computer. A machine would read the cards by shining a light through the holes. A hole meant yes or 1. No hole meant no or 0. This was a very slow and careful process. If you made one mistake, if you punched one hole in the wrong place, your whole program could fail. Think of it like a music box. The little bumps on the cylinder tell the music box which notes to play. The punch cards worked in a very similar way. This was the very beginning of giving machines instructions. It was clumsy, it was difficult, and it took a lot of time. Writing a program that could do simple math might take hundreds or even thousands of cards. It was a job that required incredible patience and precision. You were talking to the machine in its most basic language. This is called machine code. It was very hard for humans to read and write. Programmers knew they needed a better way. This need set the stage for the next amazing invention, the first real programming languages. The 1950s were a time of big changes. The world was building bigger, faster computers. But programming them with switches and punch cards was just too slow and too hard. Scientists and engineers needed a better way to talk to these machines. This led to a breakthrough idea. What if we could write instructions using words and math symbols, and have a special program, called a compiler, translate them into the ones and zeros the computer understands? This gave birth to the first high-level programming languages. One early superstar was Fortran. Fortran stands for Formula Translation. Designed in the 1950s by a team at IBM. Its goal, make it much easier for scientists and engineers to write math programs. Instead of hole patterns on cards, a scientist could write something that looked like a math equation, like x equals sine y plus z. The Fortran compiler did the hard work of turning that line into many machine code instructions. This was revolutionary. Around the same time, a business need emerged. Businesses were starting to use computers. They weren't solving complex math. They needed to manage employee records. They needed to track inventory. They needed to handle payroll. They needed a language for business. So COBOL was created. COBOL equals sign, Common Business-Oriented Language. It was designed to be very readable, almost plain English. Example: subtract tax from gross pay giving net pay. The goal? Make programs easy for business managers to understand, even if they weren't programmers. Fortran and COBOL were the first explorers in a new land. They were built for different jobs. Fortran, science and numbers. COBOL, business and data. For the first time, people could choose a language right for their problem. This was a huge deal. Different problems needed different tools. By the 1960s, computers were still huge, expensive machines. They were mostly found in big universities, large corporations, and government labs. Programming was still a job for specialists, but some people had a different vision. They dreamed of a world where anyone, even students, could use computers. They needed a programming language much simpler than Fortran or COBOL. That language was BASIC, Beginner's All-Purpose Symbolic Instruction Code, created in 1964 at Dartmouth College. BASIC used simple English words like print, input, and go to. A student could write a simple program in minutes at a terminal. The real explosion came in the 1970s and 1980s with personal computers. Apple II, Commodore 64, IBM PC, most shipped with BASIC. For a generation of kids and hobbyists, they typed programs for magazines, created games and drawings. They experimented. As computers became more powerful, people wanted to do more complex things with them. They needed a language that was fast, powerful, and flexible. In the early 1970s, a programmer at Bell Labs named Dennis Ritchie created exactly that. He called his new language CC was different. A perfect mix of high-level and low-level programming. Code easy for humans to read, but also capable of powerful low-level tasks. As we entered the 1990s, a new frontier was opening up, the World Wide Web. The internet was connecting computers all over the planet. This created a brand new problem. How do you write a program that can run on all these different kinds of computers? This is where Java came in. Developed by Sun Microsystems with a powerful slogan, write once, run anywhere. This was a revolutionary promise. By the late 90s and early 2000s, programming had become very powerful with languages like C++ and Java. But with that power came complexity. A programmer named Guido van Rossum thought there should be a better way. He wanted to create a language that was powerful but also easy to read and simple to write. He named his creation Python. Python's main philosophy is readability. Today, Python is used for websites, automation, data science, and artificial intelligence. Today, we live in a world filled with a wonderful variety of programming languages. The journey that started with punch cards has led to a rich ecosystem where there is a special tool for almost every job imaginable. We have dozens of popular languages, each with its own community and strengths. For example, JavaScript for interactive websites. If you're building an iPhone app, Swift. The world of programming is constantly changing. New languages are created to solve new problems. Google created Go for fast network services. Mozilla created Rust focused on safety and speed. Our journey through time has shown us something amazing. We've seen how programming languages evolved from simple holes in paper to sophisticated tools that build our digital universe. Think about your daily life. Your alarm clock app wakes you up. You check weather on an app. You drive in a car full of small computers. These secret codes are the language of our age, like a paintbrush, chisel, or construction set. They let us build the future, one line of code at a time. Understanding this story demystifies the technology around us. The digital world wasn't delivered in a magic box, it was built piece by piece, line by creative people. Learning even a little programming can change how you see the world. It teaches logical thinking, breaking big problems into smaller steps, and creativity. It's becoming as important as reading or writing. That story involves every single one of us. It is, quite simply, science. And it's awesome.